All right, here we go. No, not quick. Has to be. All right. It's running SUBPG. Oh, because I have that. Okay, this cable is bumping me. Let me. There we go. All right. Oh, wait, no, I thought that should have actually. This looks like it's localized correctly. Or localized is not the right word. Yeah. So why? Oh, it is in there in data. Wait, so why didn't that load? Working directory. All right, so here's STB connected components, still running, and I did this work for my friend who works on Clockwork Empires, which is an upcoming indie game. It's in early access right now, and they were hooking it up, and they had an issue, and they wondered how to deal with that issue. And so I thought I'd dive in here and see if it was possible to do a better job. But I don't think it is, and we'll take a look. So the issue that they have, so the job of this program is to take a map, to take 2 points on the map and answer a query, can you reach one from the other? Or is it impassable? Is there something impassable in the way? So it's a little like pathfinding. but it's simpler. We don't have to return the shortest path. We don't have to know how long the shortest path is. We just want to return, is there any path? In fact, the reason you want this is because pathfinders can be very slow if there's no path between two things, because they have to discover that, and they have to discover it every time they pathfind. The properties that relate different pathfinds to each other, sort of transitiveness, are much more complicated than the transitiveness of can you get from one point to another point. And so it's much easier to build a data structure that can answer the question, can you get from one point to another point, than it is to build a data structure that can say how long does it take to get from one point to another point. So that's what they use it for. But in practice, they have multiple types of creatures that traverse the world, like in a classic RTS. You'll often have creatures that can go on the ground and creatures that can fly. And creatures that can fly can effectively walk over water on the ground because they're flying over it. But they can't go through each other, maybe. And maybe there are towers or something that stick up in the air that do still block them. And the easiest way to deal with a thing like that is to simply keep two sets of reachability data structure. One is the reachability for creatures on the ground, and one is the reachability for creatures in the air. And in Clockwork Empires, they have three types of creatures that have these sorts of rules. And so I told them, yeah, just go ahead and make 3 copies of the STB connected components data structure and compute them independently. And the question we want to answer today is whether it's possible to reuse a single one for multiple queries. And it certainly is in theory. That's a thing that you could do. But the current memory usage will go up. Of course, if they have to keep 3 or 4 copies of it, it might still be cheaper if we expand it. But it will hurt this library use for other people. So what we're going to do is, if we may just back all this out if it doesn't work, but we're going to put it in an if-def for whether we have this notion. So so the core operation we want to know we want to support multiple types of terrain, so we'll call that type. We're going to limit the number of them to probably to 16. We might make it more dynamically definable. We'll look at that in a second. That's a bunch of memory usage. The existing code stores 1 bit to store the terrain type. It's open or closed. And so we'll need to store 4 bits, or, to store 16 types or whatever. Which, is actually more than just storing 3 copies of it, 1 for each type that goes. But I don't want it to be hard coded to the Clockwork Empires requirements. So it's because I'm not getting paid for this, but this is just, I'm figuring it's a common thing that you encounter in games to have that kind of rule. You also have like two things of different sizes, so they can fit through different gaps. And so it's worth seeing how hard it's going to be to do that. So here we want, basically we want, naively we want a flag, which is a bit flag, which is which types of the terrain can you cross through. If we only have 16 types of terrain, we only need 16 bits to encode that. But we're actually going to also have an explicit type, because it turns out we want to pre-compute all that stuff anyway. So we do need to explicitly know upfront what the rules are for which types move on which things. I'm not necessarily going to fix everything in the API here yet. It's relative to a mover type. So, and this API has not seen enough. This library has not seen enough use out there that I mind breaking the API right now. All of these would just be 0 if you're not using the multi-facility. But I don't want to bother type defing or if defing out the single parameters from them, so I'll just do it always. For the connected component, it's not necessarily you just need something to remap it. I think that's what I meant. The idea here just being that you can actually query get unique ID for that this query grid node connection really is just calling get unique ID twice for the 2 coordinates and checking if they're the same. Which actually means you don't need the mover. Oh, you do need the mover type. Yes, and this then needs the mover type because there's actually multiples per square. So the main thing I wanted to do, though, is just try to investigate how the size will change. Because if it's bigger than just 3 copies of the current thing, then it's pretty surely definitely not worth doing. So SCBC, grid, malloc size of, boom, we print it. Okay, so let's run. Oh yeah, I've changed all these definitions. Do I have the old output from before I changed them? No, I don't. Oh yeah. The SCB libs be used for a 2D rendered bitmap-based non-accelerated low-resolution game like Nuclear Throne. Well, sure, some of them can be like. You can use the text rendering. You can use the Vorbis decoder. And you can use the stuff that's not graphic specific. If you thought about spending leftover time after rendering to pre-calculate stuff, rendering what? Are you talking about OBPG, which we're not actually working on? Let me put up a note about that. Right, I was running it so I could see how big it was. 6688 788. because of its, just go down. Oh, I'm in the wrong file, no wonder. Come on. What? 6688788. Was that what it was? Yeah, okay. All right, so so yeah, so git stash apply. Okay, I don't know why that changed, but whatever. All right, but I'm not actually going to make the code changes, actually, so I do actually just want to back out those prototype changes, because I was just sort of putting them in to explain the idea. I mean, I might make the code changes if it doesn't seem outrageous. I just suspect it's going to be outrageous. So anyway, you can see that's pretty big, right? That was 7 megabytes to store this thing. And the reason it's 7 megabytes is because we allocate the worst possible size we might ever need, so that there are no allocations while running. And there's also actually no pointers internally in it. And so we tell you the size, you have to allocate the whole size, and then you pass it into us, and you can actually save that thing to disk, and it will work. Although it will not necessarily work if you load it on a different platform, because it has to pack bits the same way. All right, so what has to change? So what this thing does is it divides the map down into, and I'll be concrete, it's all flexible depending on the map size, but we'll be concrete and say the map is 1K by 1K, and this splits the map down into 32 by 32 chunks. Each chunk is 32 by 32. So there are 2 to the 10 items in each chunk. And then what it does is within a chunk, it says which of these grid squares, cells, grid tiles, I don't think I use cell elsewhere. So which of these grid cells are connected, and it builds lists of the connected ones and stores them. And it calls it a clump. So you can see it's limited to storing up to 32,000 clumps in a single cluster. So we're looking at the cluster thing. And it actually has many more clumps than edge clumps, and we'll take a look at what that's doing. And then this is just a flag. So let me see where we build a cluster. Okay, so that's a cluster, max clumps per cluster, 8 times. Why is it 8 times 2 to the 9? SCBCC max clumps per cluster. Okay. Max exits per cluster, max clumps per cluster, log 2. So it's what? -1. Okay, so the idea is that if you built a checkerboard of open and closed spaces, then each open space would be its own cluster. And the checkerboard is half of the map, and so the max number of clusters you can have is half the map. So that forces us to store. So I was saying there are 2 to the 10 cells in a cluster, so there are 2 to the 9 possible clumps. And then each one is apparently 8 bytes. And so you can see this takes up 4 kilobytes per cluster, but then there are 1,024 clusters, and so that becomes 4 megabytes. So you can see that's where most of the storage goes. So down here, SBCC cluster is what's accounting for most of the storage, 4.5 megabytes. This table, clump for node. So yeah, that's storing 2 bytes. What is clump ID? I see global clump ID and relative clump ID. What is clump ID? Anybody see where the definition of a clump ID is? It must be earlier. Oh yeah, it's part of the API. Oh, it's not part of the API. It wouldn't have the underscore in it if it were part of the API. Okay, it's just an unsigned short. Okay, so as expected, that's 2 bytes, 1K by 1K. That takes up 2 megabytes. Okay, this naively doesn't have to change. The map does have to change because this map is storing 1 bit per square, and we now want to store up to, say, 4. So let's introduce this multi-typed, typed, terrain type, modal, call it typed. Yeah, when I say open and closed, I mean walkable and not walkable, which is totally confusing if you are used to A star, which also has open and closed. That means something totally different. Yeah, and this is very explicitly not targeting the infinite world kind of stuff. This is very explicitly assume you have a closed-sized map, and how good can we do? You can look at the original video about this. If you want to see the premise and how it works and why it works the way it works. I don't think it's worth rehashing that too much right now. I'm looking up the video on YouTube. Here it is. Which covers why you do it this way at all, as opposed to just doing a full flood fill every time it changes. This is an optimization. The naive thing you can do is just do a flood fill, basically a flood fill. You flood fill from somewhere, and then if you haven't filled everywhere, you start from somewhere else and flood fill from there, and repeat that. And that's just, you have to do that every time you change the terrain. You have to reflood fill. And then there's a thing called the disjoint set forest, which can efficiently merge when you add a connection. It can efficiently merge things, but when you remove a connection, it cannot efficiently update. So I wanted to make, and very efficiently, I should point out, that thing runs in order 1 time. So I wanted to add something that runs at a reasonable speed, even when you are deleting connections as well. And so I came up with this, and it's hard-coded to the idea that you're on a grid, and it, on a grid of n nodes, it takes square root of n time, basically. The kind of logic that it does here is not suited to SIMD. But also it's hard to write portable SIMD code, so I pretty much never have SIMD in the STB libs. The only one with any SIMD is STB image. because once that reaches stability and a certain size of audience that it's reached, it becomes worth putting that kind of stuff in. All right, so now let's, so the main point though is that checkerboard thing, right? Is that, you know, here's the worst case in terms of size usage in the old thing. Oops. Okay, let's make it 8. Is you have a cluster that looks like that. You know, if you have a cluster that looks like that, so it's, and we're using 8x8 clusters here, 64 things. There are 32 clusters in here. All the dots are clusters. But there are some interesting observations. All the clusters do occur, and how do we do their global ID? I don't actually remember. Is the global label 4-bit? Global label. Global clump ID. It's got room for, yeah, it is global. We store a full 32-bit number. There's room for 2 to the 12 clumps per thing. So each, which is more than enough. This case has 2 to the 9. You can bump up to maybe 2K by 2K, but then you're gonna run into this limit if you tried to make a 4K by 4K map, maybe. So as long as our clump indexes are 12-bit, those don't need to get any bigger. So one thing we have to do is we have to say if def stbcc typed we no longer have one global label. We have one global label per type, per mover type. And in the particular case that we're talking about with Clockwork Empires, that would be 12. So that would become 16. So STBCC clump doubles in size. Num adjacent, max adjacent. Those are all okay. Adjacent clump list index this. Okay. So let's find num edge clumps and see how this code actually uses these things real quick. Oh, I see. It's the number of clumps that are located on the edge. Yep. Okay, so one of the premises of this thing is that you'll merge clumps if they're connected. Wait, its dots are connected. These all become one clump. Right, these are all numbered 1. And let's make it, I'm trying to find something that stands out from the X better. So let's just make the X's lowercase. So if there's some other one in here, it would have already been merged in if there were a connection between these. It must be disconnected. And so what we know is that any clump inside the cluster, all of its connections are to outside the cluster. They're never connected to inside the cluster. So 1 and 2 can't be connected under the old traditional model. And as a result, a lot of these numbers are pretty limited. The number of clumps, so num edge clumps is which clumps are actually on the edge so that they might even participate in this. Because when you have that full checkerboard, all the spaces in the interior, you know, O2 floods out to here. Okay. You know, something like this can't connect to anyone. 3 can't connect to anyone because it doesn't live on the edge. And so there's no room for there to be an edge. 4 and 6, or 4 and 5 and 6 can connect to something on the right outside of that cluster, but 3 can't. And you can bound the number of things that live on the edge to be, half the perimeter here. So it's 16. But dynamically, you can say, 3 just doesn't even have to participate in this. The only ones we have to worry about are the ones. So that's what num edge clumps is. This is a flag while you're building. This is clump, which we already looked at, and I thought I computed the correct thing. So this doubles to 8 megs. And then clump ID adjacency storage. So adjacency storage is used to say, to store, 5 connects to 3 in the next block over. So it has a cluster dx and dy to tell you which direction you have to go on the clusters to make this connection, and the clump index, which is which clump it is in that thing. So in the old scheme, you can only have connections from an edge to an adjacent thing. So, and you can't have every, suppose these were all the same. Suppose we deleted those edges, and this was all one thing. How many connections out can this have? It can have connections like that to the next thing, but it can't actually have connections like that, because over in the next one, say these are numbered 3, 5, and 7. These have to be separate things. These can't be connected either. If these were connected, like if 3 went around this corner and was connected to here, to 3, we would only store 1 connection from 4 to 3. We wouldn't store 2 connections to 3. Right? We would store those connections. And so as a result of that, the number of connections from the one cluster to the next cluster can be bounded by the same half the perimeter. So the perimeter in this case is 8, 16, 24, 32. It's actually 28, but close enough, 32. And then half that is 16. So if we look down here, SBC cluster adjacency count is max exits per cluster times 2. Why is it times 2? So why is that per cluster? Oh, clump, right, clump, not cluster. Max exits per cluster times 2. Why does that have to store times 2? That doesn't seem right. Max exits per cluster. Yeah, that's half the perimeter. And the max exits per clump, I don't know if I still use that, is just because you could fill a whole cluster with 1 clump. So the max exits per clump is the same as max exits per cluster in this design. What do I use max exits per clump for? I only use it for assertions. Okay. Yeah, I'm not solving pathfinding though, so I don't care about the performance of pathfinding. That's on the people who are using this library. The only purpose of this library is to speed up is to avoid the fact that you will spend way too much computation on an unreachable pathfind. And it's not to speed up that pathfind, it's to avoid spending the computation on it. It would be fine if you launched the pathfind and it ran in the background and 5 seconds later you said it's unreachable, except that you spent all that CPU power on finding it was unreachable. The problem is that for some search algorithms, the non-reachable is actually a worst case because you basically flood fill what is reachable in searching for the unreachable thing. And flood fill it. So 2 things are really close to each other. Normally a pathfind between them is very fast because it only really explores the area right between them. If it requires a roundabout path to connect them, it'll explore a lot more, however much it needs to discover that roundabout path. And if it requires even more, because it's a super, super, super roundabout path that goes over the whole map, it'll search the whole map. And basically, search algorithms don't understand geometry, and so even though you're now exploring in a direction that it's totally, like, you say your search has totally surrounded the spot that's unreachable. You know, say somebody has a locked door, they're in a shack with a locked door, and you've searched all around it. There's no geometric understanding that you've cut off all possible ways into it. The search formalism allows for the possibility that somewhere there's a teleporter that teleports you straight in. So just keep searching and keep searching and keep searching, looking for that teleporter, which you don't have any teleporters in your game. Doesn't matter. The search algorithm supports that kind of idea, and so it searches everywhere because maybe somewhere there's a teleporter right into that thing. And so if it's unreachable, you will always hit this worst case. It then also does serve to reduce that time problem, because it does let you give immediate feedback and stuff like that. So as I was saying, this checkerboard case gives us more problems now, because now the whole thing is that now, instead of being passable and impassable, we have two different types of passability. So we have, dots and colons. So now our worst case is a checkerboard of two different types of passability. Okay, so what is the algorithm going to be? What we currently do is we compute these connected clumps within a single cluster. And we want to do the same thing. We want to compute connected clumps within a single cluster. But now, and in the normal case, suppose you had something like this. Suppose we put some impassable terrain in, right? Like the checkerboard map does not correspond to anything in the game that we're concerned about, but we want to be robust and work. So, for example, we have to make sure our memory case works for the worst case, even though we don't care that much about the performance. So, say you have some terrain here, and then you have some water, like this, and so you have one type of creature that can go through water, and like type of creature that can only go through land, and such. Okay, so when you go on here and you find your connected components, well, the dots are all going to be, let's at least make it a little bit, let's suppose there's a little water over here. And suppose there's a little, path out to down to the water, like this. All right. If you were doing this for a creature, if you just solved this whole problem for a creature that can walk on the ground but can't walk in water and can't walk on the solid, the other stuff, then you would just turn this into this. Oh, I see. I haven't gone far enough. Right, you would just go, okay, I'm just going to replace that with this. Here's the reachability for this guy. And you solve this problem, and it's all, the existing code is exactly designed to do this. Right? And then if you want to have another type of creature that can walk in water, you would make a second one. And it just looks like this. Right. Boom. So this is the naive way to do this, is you just implement two reachability grids, and solve these problems separately. And if you do that, this is super efficient, because now this turns into one clump, right? All of these are connected. We can stick in here, we can stick ones everywhere. Right, these are all ones. Everything is connected. And over here, same thing. We can say they're all connected. Everything's connected. It's a different set of connected areas than in the other one. If we want to share the data, right, then what we want to do is kind of come through and say, well, these are all the same type. We still want to reduce them to as few connected things as possible. These are a different type. And this is the other type. Now here it's how many connected components, right? So even though this is the same type as this, 2 and 3 are the same type. They're not connected to each other in this cluster. And in the old algorithm, when we had this kind of scenario, the 2 and 3, that was because they could only be connected externally to the cluster. So we only had to keep track of their external edges, adjacencies. But under this new model, the idea is that at runtime, well, it'll be a pre-compute time, but we're going to say, oh, we have a guy who can only walk on air. Let's compute the reachability for a guy who can only walk on air, and he can only visit ones, and it'll have connection to 2 and 3, and it'll ignore them. Well, let's be more explicit. Let's handle the easy case first. You have the guy who can walk on water. He's going to say he is allowed to walk here, he is allowed to walk here, he is allowed to walk here. So when it does the reachability analysis, it has to know there's a connection between 3 and 1, and it has to know there's a connection between 1 and 2. And it'll have to explore these 3 things together in this cluster all at once, which the current code never has to do, because it only ever worries about there being connections to adjacent clusters. If the guy can't walk on water, then he can't walk in 3 or 2. But we're going to store connections between 1, 2 and 1, 3. So we'll have to look in those connections and go, well, we're in 1, and then it connects to 2, and we'll have to check, is 2 actually a type we're allowed to walk on? We'll have to actually actively check that. But the main thing is that then if you have a checkerboard of, say, the water and the walkable thing, then each of these is its own cluster. There's a cluster A, a cluster B, a cluster C, a cluster D, or not cluster, clumps, sorry. H, I, J, K, L, M. Every single one of these is its own unique cluster. And when we do the reachability analysis, if you can walk in both types, we have to dynamically merge all of these. So it's going to be super slow in this worst case. They never have the worst case in their game, so I don't care about that too much. For the performance side of it, we'll have to see. I think having to visit a few extra things here is not so bad, but it's definitely a little slower. What I'm worried about is the size, because I have to store all those connections. So clump index we said was fine. We did with these. How many cells, how many connections can you need to have? Well, if you, the biggest cluster, like, suppose you have a cluster like this, a clump like this. That snakes through, and then you can actually, let's see, both sides of that. This is actually too small an example. I need to actually go to double the size to make sure I hit the worst case correctly. Like this can be, there can be a, these could all be unique clusters, right? If you have enough terrain types, then you can checkerboard, you can put down a checkerboard of terrain types. And then have a third terrain type going through this. And that third type has connections to the ones on either side of it, right? So the worst number of adjacencies you can have is to tile this pattern where now the letters are supposed to be totally different, right? This is actually M, N, O, P, Q, R, S. you only actually need these connections on one side, but this also allows me to add connections out to the exterior. So it looks like 1/6 of your spaces are full. Well, so every single one has two connections adjacent to it. Every single thing, but the upshot is within a single for a single clump, the most you can have is if we allow our clump sizes to go up to a cluster size to go up to 64 by 64, then that's 4/6 of that. So whatever that is. $2,000. And then let's check what 32 by 32 was just for 600. Okay, so currently, the current code assumes that the number of adjacent things to a different clump, num adjacent, max adjacent, fits in a byte. But in fact, we'll just expand all of them. But in fact, it needs a short under the new thing because of that math I just did. Okay, so now this is 2, 4, 6, 8, bumps up to 20, which bumps this up to 10. Okay, and then adjacency storage is currently only 256 bytes because you could only have connections from one cluster to the next cluster. But now we have all these internal cluster connections. And we can still use the relative clump ID for it. The whole point of this, though, is that we are just looking at the maximum exits globally. And that was 64. Oh, this was the thing where I was like, I don't know why that's times 2. I'd have to watch the old video to figure out why that's times 2. Is that storing something I don't know about? I can't think why that would be. I have no idea how this code works. We're just deleting it from the middle without having any idea. We don't delete the list properly. Oh, I see. Yeah. Not relevant. Where do we compute clump list index? Oh, I'm not searching for it. Okay, here. Build all connections for cluster. So we only traverse the edges, And then along the edge, we check if there's a connection across the edge. And we count out how many there are into num edge. Oh, right. We do this thing so that we can incrementally expand it. I forgot about that. That's why there's the max. Do we ever actually do that? Yes, we do. Add clump connection. Right. There's this intentional design so that we don't have to rebuild things. Okay, I remember this now. All right. And that is why there's extra. We store twice as many so that we can expand it dynamically without having to force a rebuild. Okay. So anyway, the point is this only makes room to store connections on the edges. The actual number of connections you need to store is, for the checkerboard case, 4 connections per tile, which is 4 times the number of tiles, which in our case is 24, times the size. Relative clump ID is 2 bytes. So that's 8 kilobytes, which becomes, so this was 20 times 2 to the 9. That's that. So so the 8 kilobyte becomes 8 megabyte. That's my guess. If def has to be 60 typed. If it's typed, then we need what's it called? Cluster size. Okay. Now this code won't work because I've just arbitrarily hacked on it, but I just want to get to run and print the size. Oh, I didn't actually define that symbol. That's why I compiled okay. I'm sure I broke something somewhere. So I lost my train of thought. Why is this still running? Okay. Oh, right. I have to turn on SBCT typed. Actually, let's do that in the correct place, which is here. Right, let's not have that fail to compile. So let's do this. Because all I want to do is get the size of the structures right. Okay. 21 megs. Where did I print that? I typed it in here in somewhere. Did I delete it again? Oh, it's up higher. There it is. Okay. I missed 21, 211, 06, 708. So it's more than 3 times as big. So right there. It's a size lose. It may or may not be a speed lose. 3.1. So it's a little more than 3 times as big. So I think it's not worth doing. I mean, that's the worst case size usage. The actual size usage may be better. The 3 copies of it is definitely going to use 3 times as much memory. Like however much memory actually gets used in terms of like is live in the caches or whatever, is definitely going to use 3 times as much memory. And this one is not necessarily. But it's going to introduce all these complications. It's going to introduce all these not pre-merged things that I was talking about in those illustrations I've deleted. So I feel like it's probably not worth doing. It's possible it would still turn out to be faster, but it doesn't seem that likely. I mean, it's, yeah, I don't know. I have not lost any weight. I don't think. Anyway, so yeah, I'll take questions on the stuff, anything I didn't explain clearly enough, and I guess whatever. And for, I don't think it's visible. I have lost like 10 pounds in the last 3 months or something, so it's not particularly speedy. So I doubt that's visible. But for those curious about those sorts of things, I changed my diet about 3 months ago to get off of really bad junk food and stuff. I don't eat that anymore. A lot of fresh fruit and vegetables, etc. But it's less for weight and more about reducing my sodium. Advice for a beginner learning OpenGL. I don't. I'm too disconnected now with what the best way to do that stuff is. My personal preference is to use supports the compatibility mode and use the compatibility mode and use old OpenGL stuff and learn the new OpenGL stuff after learning the old OpenGL stuff, because I think it's a lot easier to learn the old OpenGL stuff, even though it's got some weird things with the state machine and stuff. There's a lot more boilerplate to use the newer style of OpenGL, where so newer is vertex buffers, shaders, and stuff like that. You can get by a lot less boilerplate and get stuff going on the screen faster without it. And but that's my opinion. I don't know. I had to learn it that way because the new stuff didn't exist when I learned. So that may just be me feeling, seeing something that's not necessarily true. And yeah, and when I learned was a long time ago, and we didn't have internet tutorials when I learned, so I don't keep good touch on that. I mean, I have used internet tutorials to learn shaders and stuff, but I was operating from a pretty different base of knowledge. I don't actively follow the demo scene. I follow people on Twitter who follow demo scene, so I see occasional demos. One of my coworkers was a member of Farbrosh back in the day. Of course, not back in the day. It's back in the day. It's, well, depends how far back you go, right? You go back to Amiga demos or go back to software rendered PC demos. And he's from the 3D GPU era demos. And he's the author of one of the 2 STB libraries that I didn't write. STB DXT, which is actually rig DXT. And then the other one I didn't write is STB image resize by VinoBS. Anything else? Anybody? Trying to think of something I can do with the stream as long as I got the stream going, but maybe I'll just pull the plug. I guess I could do some pull request processing. Oh, I forgot to actually tag. I read this already and forgot to tag this. Bug. Oops, wrong button. I assume I must have used %p or something. What is Z? I don't even know. I obviously used it myself. Z is not supported. Why does my code have Z? How to approach a new and complex problem. I probably would need a concrete example to really think about that. Or how to cut into a new system language. Yeah, I'd probably need I'd probably need a more concrete example than that too. Like I could totally believe that Z is, because the whole point here is it's printing size T, I think. That Z is not standard, but why would I have used something Microsoft C doesn't support in my code? That just doesn't make sense to me. Yeah, unfortunately, I don't have the help docs for VC6 installed, so I can't actually just look at the docs. Yeah, Z of size T in a non-standard way. Okay, maybe it's C99, but Microsoft apparently didn't implement it or something. For example, I need to read bits off the GPIOs of a Raspberry Pi as fast as possible. Like I have to do it in ASM. Where do I start? I guess I would start by looking on the net to see what other people are doing, if you can, but knowing that they're not necessarily doing the optimal thing. But, you know, see if you can find working ideas for it. I mean, like grossly, you divide certain problems into sort of interesting problems and uninteresting problems. That's not really. I don't want it to be pejorative. So like that's not really a useful thing. But like if you've played TIS 100, some of the TIS 100 problems have an unexpectedly broad range of possible solutions for you to explore. Another example of that would be the Atari 2600. If you've ever read anything about how that thing is programmed, like a cursory exposure to how that's programmed, like something like Racing the Beam, will give you some idea of the challenge of it. But if you ever actually look into the details and look at how people do things, skip draw, let's say. This is people trying to figure out how to render a sprite on the Atari 2600. And so like here's a sample routine for rendering one row of a sprite on the Atari 2600. And there are forums devoted to figuring out what's a better way to do this, a more efficient way, because you are quote unquote racing the beam. You only have time to update a small number of registers, and so there's a direct correlation between production value and how fast your code is. The faster you can make your code, the more production value you can pack into it in a very direct way in the Atari 2600. And so that's an interesting and deep problem. And so the question becomes, is reading bits off the GPIOs of the Raspberry Pi an interesting problem or an uninteresting problem? And I don't mean that, again, in the pejorative sense. What I kind of mean is like, is it this problem that is sort of solved? It's like, well, you know, the maximum rate that you're allowed to read the bits in the first place is this, and here's code that reads them off at that rate, and there you go. Or is it more like hey, it turns out if you do this fancy exact set of operations, you can get a little bit faster. And so the answer to that question depends which of those spaces that thing falls into. But even being able to answer that question pretty much requires you to already have a pretty deep understanding of the problem. And of course, so I think, like, to the degree that people in my peer group, or like the handmade dev type people, are maybe critical of the Stack Overflow kind of stuff. I mean, partly it's because you get bad answers from Stack Overflow, but partly it's because if your idea of how to approach the solution is to go find the thing on Stack Overflow, or equivalently this thing, and type that in and you're done, then you're treating it as the uninteresting problem without actually knowing whether it's an interesting problem or not. And if what your approach is to go on Stack Overflow and find a solution that works, and then dive down into the problem further and say, well, can you do better than that? Is it an interesting problem? Is it a problem that has a surprising set of possibilities or whatever? So I'm trying to not answer the specific question. I'm trying to answer the general question here. The exact details of that specific question, may or may not, this may not translate that well to that specific question. All right, so I don't see any other questions that I can actually parse there, so let me go back to this. So again, the question, though, is why I had Z in here, and why this person then thinks ZD is better. And that's basically a research problem. I need to actually go into my code and figure out if the Z is working and why I had the Z. I kind of need to install the VC6 help to find that out. And then I need to find out what the current standard is, because I can't trust somebody else's submission like this. This is too often, and nothing personal about this person, just too often these kinds of fixes are like, oh, this makes it work on my machine, and it needs to work on everyone's. And obviously mine didn't work on everyone's. That's a bug in mine, that it doesn't work on everyone. But fixing that bug by making it work on somebody else's machine is not actually a good solution. But I'll go ahead and flag it as a bug. And I don't think that there's an STB leak check. So that's a library with no tag. Yeah. So, I mean, kind of the answer to your question was like, well, how exactly would I dig deep? And it's form searches and, Stack Overflow and, or Stack Exchange, I guess, in this case. I mean, partly you have to pick what battles to fight. I'm pretty bad about premature optimization and not picking my battles to fight. But as I've gotten older, I certainly do that more, just because you don't have infinite time to do everything. And so you have to decide whether this is a thing worth drilling down into. So how important is it that you read GPIO pins as fast as possible? Is there a fast enough that you can stop at? But I do certainly advocate deep drills. Deep drilling is totally a good idea. Like getting down to the nitty gritty of what's going on under the hood is super appropriate and worthwhile for a certain style, for a certain type of coders. In STB connected components, this work that I was just doing, I didn't actually write any code at all. What I was doing was drilling down exactly into the memory usage. So, I ran the program in the end to find out how big the data was, rather than trying to add up the numbers that I had here. But I had, in fact, done this work to compute that the cost of clusters should have been whatever. This is 4. So the cost of clusters should have been 1K times 4 plus these two, 18 megabytes. And then this is 2 megabytes, and this is relatively tiny. So I came out to 20 megabytes. And what was it, actually 21? Oh, right, it's the other file. Yeah, 21. So I might have missed something here, or it might just be that these numbers do actually add up to 21 if I do it right. And the point here is that I could have just made these changes without trying to figure out the numbers for myself, but then I would have ran it and I would have been 3 times bigger, and I would have been like, 3 times bigger? That seems crazy. And I would have had to drill down into why it was 3 times bigger. And so I was just upfront doing the math so that I would have a sense of it already, rather than drilling down after the fact. I just went ahead and drilled down as I was going. And so that's drilling down into this memory usage in a way that you don't always need to. You don't need to know where every byte is going. But in the STB stuff, it's a little more important. And in particular in this case, because I allocate the worst case size up front, so that there's no dynamic memory allocations. The worst case, like the version 1.0 of this actually allocated a lot more. I don't remember how much more, because I didn't do all this math to figure out what the minimum size was. And yep, there you go. It used to be much bigger than even this proposed one that I was saying, oh, that's too big. That's 3 times bigger. It was originally much bigger. I'm not sure why. Did I do that math wrong? I don't know what this math was doing. 1K times 1K again. Why does it multiply 1K by 1K? I have no idea why it's doing what it's doing here. This is twice as big. This is the same. Oh, no, sorry, this is the old size. Max clumps per cluster. Max clumps per cluster was just 1/2 of the thing, right? Four, 5, 6. Oh, because I stored max exits per clump in each clump. Yeah, so that totally blasted out my storage. So yeah, anyway. So yeah, it probably was 64 megabytes. And I don't even remember now. Why did I bring this up, that it used to be much bigger? No idea. Yeah, the single line comments have been a feature of all compilers since long before C99. So you could use them safely even though they weren't in the standard. Anyway, I lost the train of what I was saying there, so. Yeah, the question about this bug is why the thing that's currently checked in is in there, because it shouldn't work on my machine. So I don't know what it is. Okay, so this is a real major, huge improvement in STB tree type that I should probably check in. What I really want to do actually is, if I'm going to put time into this, is try to finish up other libs. What I'd like to do is actually fork other libs into a new repository. I don't know if there's a good way to do that while preserving the history, though. Because at this point, other libs has become a significant fraction of my pull requests and issues. Alright, so let's revert this. Let's save it first. Got connected. It's .h. What's changed in this? Oh, tests. Oh, I added those numbers. Yep, okay. And let me tweet. Check my notifications. Oh, all right. Yeah, by the way, this is how, just in case you guys missed it, this is how long it takes me to exit and restart it. It comes up instantly on projects of the size that I have. How long does it take me to bring up OBBG? What? Oh, I brought up OBBG. Welcome back to STB. There's lots to like about BC6. All right, so I checked those out. So what's my status here? I think those are probably real fixes. Yeah, they are. All right. Oh, I haven't added SVPG though, so I didn't really need to check that in yet. But whatever. So we want to play with this. Working. Let's look at what the change was before actually committing it. The lightest feature rich. Yeah, that's a little bit editorial. Let's fix that. Yeah, let's just drop all that. C++ is implied. Single header is implied. Hey, look. Let's just give it the same name as everything else. Although I don't know it's actually unit testing. All right. Okay. That'll fix that one. What else we got? Anything else that would be other libs? Yeah, this is a problem because did he fix the code generator? No. Yeah, he directly edited the thing rather than fixing the code generator. Oh, no, he did both. Yeah, that's probably worth doing. Is this formatting right? It looks reasonable. Is that going to compile okay? Why does it lose the... Oh, he actually changed the columns. No, he didn't change the columns. Why are there pipes? Why does it lose the asterisk? Oh, I see. He added it outside. Yeah, I think that seems reasonable. Let's actually do that though. Oh, I'm already unworking. When did that happen? Oh, because I did that up here. Okay. So now the README is totally out of date, but then the make README, I need to rebuild. Do I have that in here somewhere? Yep. And then do I have a batch file? How do I, oh, it's tools. Debugging README, okay. So that should work. Okay. Why does that not work? Oh, because I have to run it from the tools directory. Okay. What happened to the... Oh, that's already in the commission, in the history. All right. Are those links actually valid? I don't think... I thought the links were named something different. If we go back to the code, what is a link name here? Yeah, see, this has this much crazier name. blob master, etc. Whereas he just made the links be the names. But he claimed he had it working in his fork. Where was that? Direct links to files. See his fork. So that turns it into the whole blob name, but that's not in the... Is it automatically doing it? Is that a redirect? Maybe that works and it's a redirect. Okay, yeah, it looks like that works. It's a redirect. Okay. So... so if we push it, which I'm going to do in a different window because it's got my password in it. Our working branch has, oh, yeah, git checkout. Git checkout master. Oh, yeah. Links. Git checkout master. Git merge working. Then we get push. Rejected. Oh, because I have to merge it first. Git pull master. Yeah, git pull. Okay. Now git push. And then we go here. We go down here, and now these should be links. Yay. Okay. So we resolve that. And in fact, this should have disappeared now when I go back to the thing. That one should be gone. Yep, because I merged it. It automatically erases it. Okay. So other libs, other libs, other libs. Here's an other libs. Is that the only one remaining? I think so. I went through and got almost all these earlier, a week or two ago. Then I still have all the ones in issues, though, that I have to add by hand. Okay. More comment. So do try to remember to add nothings if you ask a question while I'm kind of in the middle of stuff, because I have to skim back through this stuff and I'll miss it if you don't add nothings in. Unless you're not talking to me, in which case I just add nothings too. It's D99, blurb, 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 blurb. And pituitary hematoma. One thing that is true is that STB-libs, many STB-libs are not really written for embedded platforms because they're a little aggressive about memory usage. Some of them will work, but some are not that great an idea. So we are now working on processing other libs update requests. Oh, good. Somebody finally is coming in and slapping down a little bit of the Linux mentality stuff that's been going on in the chat, which I have allowed to go because I don't want to censor. People are entitled to their own opinions. I am not available for hire, but you forgot to put nothings to at the beginning of that. I have a full-time job. I was wondering if you'd add Janet, and he didn't even include a link. Oh, it's a pull request. Never mind. So command line instructions. Metapad libs.md. No. And then let's look at the diff. Okay, the only line that's changed is Canan. General purpose neural networks. Okay, that's a little too vague. Okay. Let's call it simple neural networks, A and N. No promise of quality. I'm not reviewing these things for quality. I used to do that, and it's just too much work. Yeah. Linux was in scare quotes. I obviously meant any Unix. No more than did I say Linux/GNU. So, you have to invert a little bit. One gigabyte of RAM is not enough. Yeah, I mean, that's the thing. It depends what you mean by embedded. If you have a Raspberry Pi with a gigabyte of memory, it probably won't be that big a deal. But in some environments, people do care, and it is a little profligate with its memory usage. Yes, like SDB image, the good loaders for SDB image for JPEG or PNG avoid having big intermediate buffers and just decode into small intermediate buffers and expand into the final output buffer. And in SDB image, we just allocate big intermediate buffers. So it maybe like doubles the amount of memory needed compared to a better one. All right, so that seemed reasonable, and I didn't commit it. How is that a conflict, guys? Really, come on. How is that a conflict? That's how it's a conflict. All right. And then that's merged working into master, so I just need to push it. All right. Oh, look, merged. Okay, so now if we go to SDB, docs, other libs, check our formatting, make sure we didn't break anything, since I do that once in a while. It all looks okay. All right. All right. So now what? Now we go and we look for other libs in issues. I'm sure that's what that is. All right, what does it do? Modal dialogues. I think I have something like that already in here, don't I? I don't remember where I put it. MISC, user interface. Because it's platform-specific windowing. I thought there was, yeah, I thought there was a multi-platform one. I just don't know what I called it. Maybe I never added it. Maybe I'm thinking of someone that never got added. Or maybe it's one of these and I just don't recognize it. Type safe printf, cross-platform, debug util, memo GUI. I don't see it. I swear I remember there being one. File open save dialogues. There it is. It's under files and file names. Now, he just called them basic modal dialogues, but it is called file dialogues. So is it actually only file dialogues? No, it is not. Okay, so maybe we don't want listed under here. So let's move the other one. Oops. Let's move them both to UI. All right. Let's closing comment. All right. None of those. And then these are all tagged, so we should be able to find other libs, other libs, other libs, other libs. No other libs. Not tagged. Not tagged. Not tagged. Other libs, other libs, other libs. This is not other libs. That's something different. Oh, maybe I got almost all the way through the other libs the other day. I just missed a couple. I remember I tweeted about it that I burned out on it. So that took maybe 40 minutes. Let me commit it. I did that change in master, didn't I? Tiny file dialogues. And we'll push it and check it. Formatting looks okay. Time file dialogues. All right. No, wait, why are these double spaced vertically here? Oh, just they got too long. It's not too bad. All right. I keep meaning to put out a UTF-8 handling lib, but I never get around to it. Because I've done a bunch of stuff to make compact UTF tables for like uppercase, lowercase, and stuff like that. Because they're these giant sparse tables. But there are libs out there to do that too, so it's not like the world is dying for them. But in the tradition of STB libs that do the same thing as existing libs, but are public domain. All right, so I think that's everything of that. So I could either work on real issues or real pull requests, or I could do that thing I was saying about splitting this out into a new repository. How hard is it to make a new repository? How many repositories do I have? Oh yeah, right, I had those. I should just delete this. How do I delete a repository? This is a thing I ended up not doing. Delete, 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 delete. Delete. I'm sure delete is a pretty rare thing, so I'm not surprised that it's not obvious, but I mean, I don't see any menu that it would be under. Settings. Which settings? My settings up here? Which thing is settings? Not this settings. That wouldn't make any sense. I have no idea what's going to be on the screen, so I'm not going to show it. No, of course that doesn't have it. Maybe somewhere in here there is something. Repositories. No, that just led me back to this page. All right, now instead of just reading what's on the front thing, the summary here, I should click to your repository. And in the main toolbar of GitHub, click on settings. This must just be old. Fucking Stack Overflow. 2012. Yep, and of course they've changed the layout since this answer. Yeah, that settings doesn't exist anymore. Yeah, I actually want to delete forks. I don't want to delete a repository. Okay, yep, same docs. Manually enter the URL for your repository setting page. Wow, that's because there's no way to get to it other than, oh, it is right there. Why did I not see that? I swear I looked there. Jesus. Oh, damn it. All right, I'm in ZDoom. Delete this repository. Is it ZDoom? I don't remember. Man, how I looked right by that so many times, I don't know. How do I get back to my page? Why am I on polls? That's weird. And then Slade settings. Wow, I did just look right by it. Let's check on the screen and see if anybody said it's right there. 6 to the right of the code tab. Points the finger right there. Yes. Okay, so everybody was watching me not notice it. All right. The joy of pair programming when the other person can't hear you. All right, so so I'm proposing to make a new repository. Is that this? So other libs. It's probably time to rename other libs to something more meaningful. Single file lib list directory. SDB directory, SDB file list, lib list, lib list. Single file lib list. That's a little too long, right? I'd like something a little more concise than that. Or do I? Or should I just call it other libs? Because people now know what other libs means. Single file lib list. Single file lib list. Oops. Well, I'd kind of like to detach it from being SDB, just because it's the whole point is it's not SDB. But like, is there a better name for single file header lib? Single file. Can you rename a repository? Can I just name it this now and rename it some other day? Okay. All right, well, then I don't have to get it right. So for now, we'll just try that. Maybe just single file libs. Naming things is the hardest problem. Single file libs. How about that? GitHub move file to new repository. I have to have git bash though. I guess I'm okay with just losing the history. This seems like a bunch of work just to maintain the history. Do I hear anyone who thinks single file libs is terrible? This seems like a bunch of work that I don't want to do given that I don't have git bash installed. I assume. I don't know how I would know if I had git bash installed. Can I say git bash? Nope. Okay. I assume it means the version of bash that comes with git, which, yeah, so. All right, I have one person approving it. That's all I need. It's a public repo, initialize with a README. Skip it if I, yeah, sure, initialize it with a thing. Git ignore none, and a license none. Yeah. I mean, what do I want to license the list as? Does the list want to be public domain, or does the list want to be under something more stringent? Great. Repository names are short and memorable. Need inspiration? How about symmetrical octo happiness? Oh, I accidentally clicked it. Single file libs. No, I think we'll stick with underscores. Well, it's a lot shorter than the symmetrical octo happiness, so I think single file libs sounds fine. All right, let's go with this. Let's go into the README. Let's edit it. And then let's not that. GitHub nothings. Docs, other libs, raw. Okay, let's update that and see what we get. Okay, I need to rewrite this now since it's not part of that other repository, but that'll do for now. I mean, that'll do as a starting point. And then we want to delete it from this one. So if we go to docs, other libs should be gone. No, it's not. Oh, I have to improve it. That's why. That's what it's telling me here. Yep, delete that. Commit it. All right. And then the STB has a link to this somewhere. It's in the FAQ, which is in here. Tools, metapad, readme.folder.md, other libs. There it is. So that now needs to link to nothings, single file libs. And then we need to run it. And then we need to push it. Oh, we need to commit it. Readme. Change link to other libs. And then we need to push it. We need to pull it first. Then we need to push it. And then we refresh. And that should now lead us to this page. Okay. Now what? Now I want to rewrite this text to not sound specific to account for the new address. And then I want to totally revise the layout of this table. And I don't know if you guys want to watch me do that. It's going to be pretty boring work. But all of this is pretty boring work. I'm just doing it because I just decided to not turn off the stream, basically, right? The reason I'm putting it in its own repository is because maintaining it, it's not that much work, but I keep like taking 2 months to update things. And so I'm thinking of trying to find other people to maintain it. Because I think it's not actually that much work. It's just when it's that much work on top of also maintaining all of my libraries, which are up to like 20 libraries now. That's more work than I tend to want to do. Okay, so how do I edit README? There we go. We should probably add my libraries to this list at this point since it's now separate. That's backwards. No, that's not backwards. Okay. Now, as a the FAQ out of date. here's the URL, which should just be that. Right, now because it could, like, I'm currently not on that at that URL. It's possible you can view this file at a different URL. So I want to keep that alive. These are all okay. Yeah, that's all fine. All right, so someday we'll add my libraries to this list, but just for now. Block selector isn't implemented yet. Are you aware of this? I looked into a pull request thing, but it seems silly for such a small change. What was make readme? Or was that already covered earlier in the stream? So make readme is this. The readme for this directory is this table and this fac. So the table is automatically generated from a list, which is this, which is a list I've made of all of my libraries and classifications for them and short descriptions of them. Then the make readme tool looks at the actual header file, goes to that list, looks at the header file, and parses out that version number out of the file and counts the lines of code and builds this table. So that this README is partly automatically generated up there, and then this stuff is handwritten. And so make README is just a tool that does that processing. What was I in the middle of saying? I have no idea. Literally no idea. I was no idea what I was doing. None whatsoever. I'd done this. I guess I was done this task and it was time to move on to another task. I don't remember. I'm basically stalling in hopes that somebody in chat will tell me what I was in the middle of doing when I answered that question. But maybe I wasn't in the middle of doing anything. Maybe I was done. So I could start trying to redesign these tables. Or something else. It might actually also be a good idea to generate this table as well, although that makes it harder for people to issue pull requests, so maybe not. So I need to set up a local thing for this. Which I don't remember how to do. Git pull, git. Is there some other command for git for creating a new repository, or for checking out a repository? Git check out repository. Git clone. Yeah. Git clone. I don't know what the correct URL is. I'm sure GitHub will tell me somewhere at the top of this. Right, somewhere on here it must tell me how to clone it. Hey, look. But I need to set it up so I have check-in permissions. I don't remember how I did that for the other one. Well, you should hear my old keyboard. If you go back to the OBBG stuff from a month or two ago or older, I had a very loud keyboard. Oh yeah, sorry. So the block selector, I wanted to answer that question. So I don't know. I don't even remember what the block selector is. I have to go look. But yeah, there's definitely stuff in the API that's not it. Which output mesh to select. So did I implement selector but not block selector? Yeah. So you just needed an else if arrow block selector. And then you need the block type to use that, which is it depends on it depends per block, right? Yeah. So mesh, is that just an integer? Where's the onside char? Mesh. Wait, what's v off? Right, yeah, so so yes. So are we about to traverse? Like, what is block point? Okay, yeah. So you just need to use star block point. So you just want where to go? Right, so you just want right here, else if input dot block selector, then mesh equal input dot block selector, bracket, block pointer sub-0, close bracket, semicolon, and yeah, make that a pull request, and I'll commit it. So how did I set this up? I gotta not expose my password again. So that's .git. There was some command I used to set it up though, and I don't remember what it was. So actually, I just want to Google what the command is again. Also, I need to figure out what my GitHub password is because I don't know that offhand. Oh, it should be in that window somewhere though. Yep, there it is. Right, so git. Hang on a second. All right. So what was I saying? I was doing git password cache store. Git config credential helper store. What's no, I just want something like, isn't there something that'll just let me type in a password? I have to make a temporary file first. I don't think I do. No, maybe I do. No, I don't have a get credentials. I did this some other way. It's in my remote. I see. Okay, it's in this. URL equals yes. Oh right, it's just a and it's a URL password. They let you do that. You're not supposed to, but you can. And that way you don't have to set up all that other crap. Okay. I don't know if that's all I need to push. We'll see. MD test, and then let's get this one into that directory. Get push everything up to date. Oh, I haven't committed. Push. Okay, that seems to have worked. So now if we do this, we'll get nothings. Single file libs. 4 people have started already. Test. Okay, good. So that's working. So now, where's that? That one. Okay, so what I'd want to do is split this up into a separate table per category. That seems the most useful thing. So let's start with that. Just do it naively and then come back and fix it up. We'll have to MBSP into every single one though now. This is just to force this to not break so that it doesn't, so that the thing doesn't get too obnoxious in its formatting. And you only have to do it in one because, well, that's nice that we have 2 different versions of 3D. Should fix that. Only have to do it in one because then that makes room. That makes sure there's room in the table, and then you don't have to do it again because there's room in the table. Geometry file, geometry math. Forgot the blank line. So I don't have any way to view this locally. I have to check it in every time I want to check what the formatting looks like, which is kind of dumb. But I don't do it often enough that I've wanted to bother getting a local GitHub Markdown generator for Windows. That's just too many things there that make that likely to be a pain. Okay. And these should go into their own tables now. Let's put this one ahead. Okay. Let's upload it. I'll have to commit it. I've lost the window that has that. Okay. Now they're all differently formatted, which is kind of sucky. And the spacing is terrible and stuff. But that's a start. Okay, so we'll do one more thing, which is now we have to pull the category column out of everything. Oh, so I didn't need to put all those MBSPs in because those columns are going away. That was dumb of me. In fact, I should have done it first. Yeah, it's actually going to be more tedious to do it now. So what I'm going to do is, because this editor has no columnar block editing, I'm going to take this into here. Go down, let's just new file it. Paste it in here, and now we can use this block editing to delete this column. No, let me add the names first before I delete that, because otherwise AI RGB audio compression crypto data structures files and file names geometry file geometry map. This is the joyous, lovely thing of being a open source project maintainer. You get to do a bunch of dumb 2D graphics 3D. Copy that to there. And then this one is 2D only. And this one is 3D only. All right. You occasionally get these dumb, tedious, busy work problems. And there's just no good way to automate it. Because it's got special cases. You have to inspect every case and make sure you're not missing something special in that case. And the amount of mouse you have to do to actually cut and paste it instead of just retyping it, it's too much work. It's not worth it. It's faster to just retype it. Maybe multi-threading would have been worth cutting and pasting. Whoops. Oops, and if I type out, it might have been worth cutting and pasting. All right, now we can cut out the block edit. Like that. We don't actually want to delete the double stars. And then some of these got indented because I foolishly added the NBSPs I didn't need. So I got to fix all those. So they're only possible if they have multi-word things. If they have multi-word names, it's possible. Yep, okay. Multi-word name. Okay, I think that's all of them. And then, wait, was it, did they have to start with a, they have to start flush left though. So I have to give up this. I don't get that convenient thing I used to get. Oh, wait, I think you're allowed to start them with a pipe. Okay, so I want to insert one space, which I can't do in this tool very well. So I'll go back to here, paste, and then select all and Alt Z. No, that deletes one. Alt, I don't remember what the command is to insert a space. Oh, I can insert a tab here. Yeah, that'll work. Then I copy it. Back here, delete 2 spaces, copy it and go back here. Okay. Then we're going to have pipe, 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 pipe. And then we copy that. And that inserts it. Can we, oh, there's no way to not insert it. Oh, so I didn't need to insert the space. Okay, now I have not inserted the space, and we just do this. Right, yeah, that was still, I didn't need to recopy that. Let's do that 4 times, copy that whole thing. Do that twice. Copy that whole thing. Oops. Do that once, see where that gets us. Okay. All right, and then that one is not. Actually, the one above it is not. Let's just switch back to the other editor. All right. Not. Oops. Dun 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 dun. Dun 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 dun. Dun 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 dun. What is anyone saying about this nightmare that I'm going through? Yeah, I'm not going to make this stuff automatic because I want people to be able to submit pull requests for it. And if you make something that generates the file, then half the time people will submit pull requests, or more than half the time, to the generated file and ignore the fact that it says generated file, do not edit. So it's easier to just let this be not generated. I could have generated just for my own use once, but that was more work than it was worth. It's only worth it if it's going to keep getting reused that way. Okay, so now that I am under the theory that I was allowed to add the pipes. I don't know if that's actually true. Why do these have colons and some of them don't? Anybody know why some of these have colons and some don't? Do they look different? They don't look different. I missed. Got to get rid of the blank space. Okay, and AI. Oh, and RGB. Okay, now let's copy those. Oh, we don't need to copy this. We're in the right spot. Check it in. Push it. I wouldn't normally give garbage things, but since I don't have the ability to view it, luckily. Okay, so maybe we're not allowed to put the pipes at the beginning? I thought you were. That argues that you're not. Let's fix one and see. Okay, but those are indented, which I'm sure will break as well. Was it -M for message? Still didn't work. Okay, so yeah, you apparently can't lead with pipes. I could have sworn you could, but, and I have no idea why those colons are in there. To change the, whether you're centered or not, maybe? Maybe those mean centered? Yeah, that one's not centered. I think that's what that is. Okay, so I was wrong about this whole thing. So all that work I did to add those, I didn't need to do. And those I just can't let be flush. All right, let's check that. Nope, I still can't do that. It has to have a blank line first. Just breaks it. If you do that, it just breaks. It's funny. Okay, but that's fine because this eventually wanted to be, let's say 2, maybe. I just had never gotten to it. Oh, crypto worked with the leading pipes. So I don't need to get rid of the leading pipes. Jesus, makes sense. And am I happy with that size of those? No, let's make them 1. Let's make them a single. Wonder if that's a markup bug, the fact that at least one of those seems like it should have worked as a table but didn't. Like, I can understand if there's something on the line before that screws it up for whatever reason, given how markup works. Markdown, I mean. What happened to the text at the top explaining what this was? I overwrote it accidentally. That's what happened to it. Okay, wait. So now this time it's not working. Crypto worked, but the one after it didn't. Is that because there's no space? Does pound something mean something else? Does that mean like put a tag in the file? Wait, I changed that one and now it works for all of them. Wait, I didn't commit it. Oh, I did commit it. Okay. I don't know. I don't know why that fixed it. And yet all those others aren't. Whatever. So let's put this back in. All right. There we go. Okay, still seems to be formatted right. And then I accidentally deleted that thing, so we need to go look at the history. Somewhere there was a big change, but this isn't telling me how big the changes are. Okay, that still has it. That does not have it. Why is that? Oh no, that's showing me the diff. It's not showing me the... That shows me the diff. How do I view the file at the time of the diff? Okay, so that's bad. Which one am I on? 5.1b. 5.1b was bad. Ah, here's the one that deletes it. Okay. That was 5e2. So this one is when it was still there. View. Raw. So I just need this. Boom. Okay. All right. All right, so I think that's it. That brings us to that. Then GitHub Markdown anchor links. Okay. So now what we want to do is say AI. I agree. And then we're going to make a table. Or actually, I guess we just make a list. Wait, that's linking to it. How do I make a... Oh, you could just use the heading. Oh, now I see. I don't have to even do that. It's just this. This auto-create, it should be auto-creating a heading for each of these. Of course, if you use the same heading multiple times, it can't, but all right. So let's see if that's right. Oops, got to close. And audio. Okay, so let's see if that works. Reload at the top. Audio. And audio is at the top. Okay, so that looks like that works. All right, so now we just have to grab all of those. Gets us to math. This is the technique I've learned for how to make header files. When you need to grab all the definitions from a file and turn them into declarations in a header file, use this technique. So that's why I have a lot of practice at doing this. One more. And in this case, let's go ahead and put miscellaneous in alphabetical order. It's a little different. And we want these to be like that. And then we want this as a prefix. Boom. Compression. Let's go ahead and do this systematically. That will be faster than redoing it every time. And you could write a regular expression to do that for you, but I should have done this one too. Okay. And this part we can copy. And we go like this. Boom. Cryptography. Boom. Data structures. Boom. File names. It's still good. I can use more words here now because these are no longer trying to be packed into the table. That's part of one of the reasons why I want to do this. Processing files containing geometry. So that I have to reorder the alphabetical order for it. Mathematics for geometry. 2D graphics. 3D graphics. So we'll just have to resort all these. Hardware interfacing. Image processing. Mathematics. Miscellaneous. Threading. Networking. Parsing. Tests. Yeah. Interface. Video. All right. So then fix some sorting issues here. H and I. Geometry file processing. So it goes next to 3D. That'll be nicer. And we could propagate these back down to the categories to actually be the official names of the categories, but I won't bother for now. A, C, D, F, I, M, N, P, S, T, U, V looks kind of sorted. I think that's it. All right. Let's test that. All right. And that. Okay, there's a typo. Data structures has two. The rest look okay, and then we need to test every single one to make sure I didn't break the link. That didn't work. Okay, I forgot the hyphens. They said I had to hyphenate everything, and then I automated it, and so because I automated it, I didn't hyphenate everything. Not sure why they didn't just make the Markdown syntax auto-hyphenate, but whatever. Okay, let's upload that. so test every single one. That doesn't work. Graphics 2D. Okay, we'll let me get a link to it. Graphics hyphen 2D, and the parentheses are deleted. Okay. Okay, 3D. Lines backspace. Not okay. 2D. Backspace. 3D. Oh, that one didn't work. Files and file names. So let's go back to near it. What does this say the link is? Files dash dash file names. Doesn't want the ampersand. All right. Well, I just assume that fixed it without testing it. Hardware. Image loading and processing. Is that actually what it is? Image loading. Yeah, there is some processing. Image resize isn't in here. Oh, right, because I haven't added mine to it. Geometry math. Should say maths, just to confuse people. Miscellaneous, multi-threading, networking, parsing, profiling, scripting, string processing, tests, user interface video. There we go. Okay, so they all work, hopefully, except for that one that I needed to upload. Which one was that? It was the one that had its files and file names. Right. So now if I reload it, click it. Yep. Okay, there we go. So now they all work. All right. I think that's it for dealing with single file libs. Announce that on Twitter. Boom. Tweeted. All right. I guess I should give it. All right, I think that's everything I wanted to do with this. So, should I do something else, or shall I call it a day? I've been streaming for about 3 hours, so maybe I'll call it a day for that. certainly. Oh, there's already a pull request. Forgot bottom of README. Yep, thank you. I caught that there was a missing top, and I forgot that there was also a corresponding bottom. Yep, yep, thank you very much. And I will just merge that automatically. Since there's nothing for it to conflict with. And it's not runnable code anyway, so if anything goes wrong, it's not a big deal. I don't do that with code, but I'll do that with this. And so we can go back to STB, take a look at what we've got pending here. Right, so there was that whole mystery Z. Fabian has fixed some stuff that I still haven't checked in from a long time ago. Many people have fixed stuff that I haven't checked in from a long time ago. These are more optional things. Yeah, this person never followed up. Yeah, so this is a thing where it's different names for these things in STB, in VC6 and VC, later versions of VC. So if it needs to get fixed, it has to actually have if-defs, and he didn't include the if-defs, and he said, okay, I'll look at it, and then he never came back. And since I don't have the newer versions installed, I'm not going to test it myself. I should install them at some point, though. So yeah, I wanted to investigate, is this replacing the existing PPM reader stuff, or PNM reader, whatever you call them, or does it augment it? Yeah, so it adds a bunch of code but doesn't remove the old code. So if the claim is that what PAM is a superset of NetPBM, then why does it not replace that? So I have to actually investigate, look at the specs, and figure out what exactly that's actually doing. That seems like a real bug. In fact, it's from Eris, so I could probably merge it without checking it. All right, right, but I always have to update version numbers, so I can't ever just use the merge built in. So I can't actually merge anything without doing the full bore work. I assume that's just a real bug. Oops, that is what I want to click. Yeah. Anything here of appealing? What's the difference between W plus B and W? Oh, stupid. Truncate to zero length or create file for writing. Truncate to zero length or create file for update. Oh, that means you're allowed to also read from it? Is that right? Somehow I didn't see this second workaround. That would certainly work fine. As long as I'm the one opening it. What is the where's the case for this? Has to be file right. So yeah, that should work. I guess I should just start now reflexively using W plus B instead of WB. That's dumb. Well, I'm going to update both input and output may be performed. Yeah, I don't think that causes any overhead, so it's probably okay to just use it. A bunch of these got fixed by Fabian's change. Yeah, that one's awesome. Yeah, I don't really feel like doing any of this. So yeah, I'm going to call it a day. So any last questions before I go? Doesn't look like it. All right. Thank you for watching. I could do some OBBG, maybe. But not this instant. Like in a little in an hour or two. But I'm not sure if I want to commit to that. Where was I in OBBG? Oh, I was in the middle of doing the machines. Yeah, I think I'm gonna skip today. So that's it. All right, thanks for watching, everybody, and see you next time.